On 4.6.
Okay.
Number 22.
4.6, number 22. Y equals x squared times x minus 4 squared. Transition point, so we want to just do everything on this one. Okay. Personally, I would simplify this first. This is going to be x squared times, I'd actually multiply this out because it's easier to take the derivatives of. So this is going to be x squared minus 8x plus 16. Okay. So y equals x to the 4th minus 8x to the 3rd plus 16x squared, right? So y prime is equal to 4x cubed minus 24x squared plus 32x. And then we can factor 4x out of that, and we'll get x squared minus 6x plus 8. Okay, and then that factors as x minus 4 times x minus 2. Okay, and to find the critical numbers, we'll set that equal to 0. And so we get x equals 0, 4, and 2 are the critical numbers. Okay, then your second derivative is equal to 12x squared minus 48x plus 32, right? And we can factor 4 out of that, and we get 3x squared minus 12x plus 8. And let's see if that factors. Okay, so if you see it before me, you gotta warn me. I can do 8 and 1, which won't work. And I can do 4, 4 and 2, which won't work either, right? If I do a 2 here, that's 6. 6 and 4 is 10. If I do a 4 here, it's 4. If I do let's see it. They both have to be negative. Does it factor? I guess not. All right, so do you see it? No. Okay, so you can use your quadratic formula. I mean, if it factors, we'll see that it does.
Yeah.
So it's going to be 12 plus or minus the square root of 12 squared minus 4 times a times c divided by 2a. So this is 12 plus or minus the square root of 144 minus, is that 96? Over 6. 12 times 8. Yeah. Okay, 144 minus 96. I'm not thinking right now. 144 minus 96. 48. Yeah, so it didn't factor. Okay, so this is 12 plus or minus the square root of 48 over 6. And 48 is 16 times 3. So this is 12 plus or minus 4 on the square root of 3 divided by 6. Mm-hmm. And then, so 4 goes into both of the, like, you can, 12, 6 is going to be 2 plus or minus, and then 4, 6 is 2/3. So those are your possible points of inflection. Mm-hmm. So what you want to do then is you can put your first derivative and second derivative on number lines. So your first derivative, critical numbers were 0, 2, and 4. And then you'll want to test values. And then your second derivative, you put on a number line -2, or sorry, 2 minus 2/3 square root of 3, and then 2 plus 2/3 square root of 3. And then just test values on either side.
So you plug those into the original equation?
No, you plug them into the second derivative or the first derivative. Okay. And it'll tell you increasing or decreasing for the first derivative, and it'll tell you concave up and concave down for the second derivative. So, I mean, I would just kind of steal it, you know. I mean, not steal it, but I would use my calculator as a tool. So we had, our first derivative was 4x to the third minus 24x squared plus 32x. And our second derivative was 12x squared minus 48x plus 32. And then you can just go to your table and test different numbers on either side.
So do you ever plug anything back into the original equation?
Well, to actually find the y value, you know, when you're plotting it, if you're going to plot it, yeah, you would. So I put 0 in here. I'm sorry, if I put 0 in here, obviously I get 0 and y1. But I don't want to do that. I want to put a number to the left of 0, like -1 in. And I get a negative. And then I'm going to 0 and 1, I'm going to put 1 in, which is positive. Between 2 and 4, I'll put 3 in. It's negative. Greater than 4, I'll put 5 in. So it goes negative, positive, negative, positive. So negative, positive, negative, positive. So that means it's decreasing, increasing, decreasing, increasing. That's the original function. That's what f is doing. So decreasing, increasing means you have a min. Increasing, decreasing means you have a max. Decreasing, increasing means you have a min. All right. Now, this 2 minus 2 squared, that number, let's just figure out what that is. 2 minus 2/3 times the square root of 3. That number is 0.845. Okay, so we could try a number to the left of that would be like 0.5. Right? And now 2 plus 2 squared is 3. So 2 plus 2/3. 2 times the square root of 3 divided by 3 is negative 12. Okay, so I decided, okay, this was about 0.8 and that one was about negative, what? Oh, sorry, it's 3.15. Okay, so 0.8 and 3.15. 0.8, this was about 0.8. This was about 3.15. Okay, so I tried 0.5, and now I'm going to try a number between 0.8, so I'll try like 2, and then a number greater than 3.15, like 4. And I'm only looking at these. Okay. And notice that they're, oh, I hit 5. I should have hit 0.5 though. Oh, there it is. Is this the 0.5? Okay, 0.5, I got a positive. At 4, I got a positive. Oh, let me try a number between 0.8 in there. Like, I thought I tried 2. So at 2, I get a negative. Okay, so I got positives, negative, positive. So what does that tell me about f? That tells me it's concave up, concave down, concave up. So these are both points of inflection. Okay, and then there's no, that the asymptotic or the end behavior of this function is it's going to be increasing to the left and the right because it's to the 4th power is the highest degree, so it's an up, up. Okay. So what you could do is you could actually go back here and go to put the original function in. We'll put that in y3. What was it? X squared times x minus 4 squared. It's kind of fun because if you look at them all 3 together, like in the standard game window, it's kind of messy. So let me do the same. See if that's maybe. Window. Well, if you go to your table, let's see. So yeah, let's make our window like negative 30. Negative 30. 30. Right, and so here's your original function. That's the one that's kind of the W. Let me change this to like, go from like 0 to 5 or 6. Okay, so that original function is like your W. Okay. So this is your, this right here is F. And then you can see the first derivative is, I'll do it in blue, right here. See, at 0, there was a min, and then there's a max at 2, and you can see the first derivative crossing there. And then there was a min at 4, and you can see the first derivative crossing there. So that's your first derivative. And then your second derivative is the parabola. And that, you know, that is about that 0.8, and then you can kind of see that would be about 3.15.
Okay.
So you can see how it all goes together.
Yeah. Okay.
Does that make sense?
Yes.
Does it?
Thank you.
Okay, sure. Is that enough?
Yeah.
Okay,
Thank you so much.
sure.